Hello, we are back to sinusoids. This is pre-calc lesson 57. We're talking about the phase shift and the periods of sinusoids. So here's the full picture of what we're going to be doing, okay? I'm going to graph y equals sine of theta and y equals cosine of theta again, so we are able to know it really well. Okay, we know that sine of theta goes through 0. We have 90, 180, 270, 360. Now I'm going to keep going, okay, to show you two full periods. So we'll have 450, 540, 630, and 720. Okay, and we know this is 1. This is negative 1. So sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is negative 1, sine of 360 is 0, sine of 450 is 1, sine of 540 is 0, sine of 630 is negative 1, sine of 720 is 0. So what I have graphed for you, this is two full periods of the sine function. And we've talked about before that the period of the standard sine function is 360 or 2 pi. Okay? Now, this is the sine function that you need to memorize. I'm also going to graph to you the cosine function. I'm going to do it a little different. I'm going to do a full negative one, so negative 90, negative 180, negative 270, negative 360, and 90, 180, 270, 360. I want you to see the full two periods in both positive and negative. And we know this is 1, this is negative 1. So the cosine of 0 is 1, the cosine of 90 is 0, the cosine of 180 is negative 1, the cosine of 270 is 0, the cosine of 360 is 1, the cosine of negative 90 is 0, the cosine of negative 180 is negative 1, negative 270 is 0, and negative 360 is 1. So, let me graph this. This is also two full periods of your cosine graph. Okay, now we talked about last time in graphing, we talked about the amplitude, right, here and here. The amplitude for both the standard sine graph and the standard cosine graph is 1. Okay, and we talked about when you change a sine graph and the amplitude, you change it by putting a number right in front. Okay, and we talked about if we have a vertical translation, right, that's when you add a number. So far we've talked about a plus b sine of theta and a plus b cosine of theta. A is our vertical translation, and b is our amplitude. Okay? Now, what we're going to do is we are going to have other translations. We are going to have horizontal translations. Okay, so it will look like y equals a plus b sine of theta minus d. Or y equals a plus b cosine of x minus d. It doesn't matter if you use x or theta, you'll see both. Okay, now we know that if we're shifting to the right, we will have x minus d. That's a d. And going to the left, we'll have x plus d. Okay? And it's the same thing if we have theta. Okay? Doesn't matter, I have theta minus d or theta plus d. Make sure you put parentheses in here when you're writing equations. It's very, 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 very important. Okay? So let me show you an example of this. If you're given this graph, Okay, so we're given this graph here. Now, what I have shown you is a little different than what you'll see in your book. In the next example, I'll do exactly what your book does. I have drawn the x and y axis and this center line of 4. Your book doesn't draw the x and y axis, they just draw the center line of 4. That is incorrect. Okay? I want you to see correctly what it looks like, okay, with the x and y axis. Now, we are going to write the equation of this graph. We first need to determine if it's a sine or a cosine graph. Now, the great thing is you can write it as either. Okay, I'm going to show you both. Let's start with cosine. So we'll have y equals a plus b cosine of x minus d. Okay, so we see that my topmost point is 6 and my middle line is 4, meaning my amplitude is the distance there, which is 2. So instead of b, I will have a 2. Okay, and my center line is 4, which means I've been vertically translated up 4. We have the cosine of x, something else. Okay, now cosine normally goes through the y-axis, right, up at our max, but now we've moved over 30 degrees, so I will have a minus 30. That's it. That's the equation of my line. Okay, now let's write it as a sine function. It'll be the same, y equals a plus b sine of x minus d. Okay, the a and b are the same, so we'll have 4 plus 2 sine of something happening to x. Now normally my sine graph goes through 0, 0, but we've moved to the left 60, so I will have a plus 60. That is my horizontal shift. Okay. All right, let's do another example. I'm going to draw it exactly as your book draws it this time, even though your book is crazy. So this is -5. This line is -6, -7, 90, 180, 270. Now it says the directions say write as a sine function, because we could have just done this as a cosine function. It specifically asks for sine. So we will have y equals a plus b sine of x minus d. Okay, so again, I look at my center line. My center line is -6, so I'll have a -6 here. Okay, and I'm going to show you, okay, the amplitude here is 1, so b is 1. You don't have to write the 1, so we'll just have plus sine. And then we will have, you'll have something like this that tells you plus theta, so we know there's a theta in here. And we see that it has moved to the left 90, so we will have a plus 90. Okay, so that is if we have horizontal changes. Now let's talk about if we have changes in the periods. Okay, as I told you, the regular sine and cosine graphs have a period of 2 pi or 360. That's our regular period. Okay, now we will have, so we'll have y equals a plus b sine of x minus d. Y equals a plus b cosine of x minus d. Okay, when our period is changed, it's because we have a coefficient c here. Okay, now what c is c is 2 pi over your new period, or c is 360 over your new period. So when we have a change in our graph, okay, this is how we can find our C. Okay, so let's look at an example. We're now going to have to combine all the things. Okay, so this is 12, this is 10, 8. We're going to have 45, 90, 180, 270, 360. Theta's going that way. We'll have this here. So we see we have a lot of cycles happening, right? And we want to write the equation of this curve. Let's write it as a sine function. So y equals a plus b sine of c times x minus d. Now we see our center line is 10. So y equals 10 plus, and my height is 12, which means my amplitude is 2. And if we look here, we are going through 0, 0. We don't have any shift, so this is just going to be x. Now let's look at C. C is 360 divided by our period. Now our period is, we go from our starting point to where we see the graph cycle through, right? Which tells me that from here to here, it's 90 degrees. So I have 360 divided by 90, which gives me that C is 4. So I will put a 4 here. Okay, you see that the 4 is making our graph go a lot. I'm sorry, this should be theta. They tell us we have theta here. Okay, we see our graph is cycling a lot. Let's do another example. Okay, and again we're using theta. So this graph, let's write as a cosine. So y equals a plus b cosine of c times x minus d. Okay, we see our center line is negative 10, so we have negative 10 plus. My max is negative 7, which means that the distance between negative 7 and 10 is 3, so my amplitude is 3. Cosine of theta, I have no horizontal shift. Now I need to look at my period. So C, my regular period would be 2 pi. Now in this graph, going from this top point to this top point is pi, which gives me that C is 2. So I will have a 2 here. And that is the equation of my graph. Okay, so as I said before, you need to know the standard graphs of your sine and your cosine. We are going to be adding on to this even more. This is not the final step. Okay, so you can spend the rest of your time studying that if you so choose, or I guess working on your other homework.